Hello, and welcome to another Into the Terminal. Today we're going to be talking about packaging RPM software. So let's dive right into the terminal, shall we?
Off we go.
Yeah, here is a Red Hat Enterprise Linux machine. I'm sorry, Nate, what were you saying?
I said, "Here we go." Like the roller coaster leaving the station.
It's so I will warn you that the critical path today is maybe going to be beyond the 5 minutes because building RPM packages is not a completely trivial task.
But Scott, we never go over 5 minutes onto the critical path. How could you?
I mean, we try to not. But at least now viewers know what they're in for before they self-select at 5 minutes. All right, so the first thing we're going to do to get ready for building RPMs is we're going to install some software. So we're going to install the rpmdev tools and rpmlint packages. And it'll pull in a bunch of dependencies. And rpmdev tools gives you the tools that you need to build RPMs as a developer of said RPMs. And rpmlint is a tool that will allow us to check the format and syntax of things. There's a whole bunch of different styles of linting around. So you may have seen an XML lint or I don't know, PHP lint. Who knows? But there's a bunch of them.
YAML.
There's
I hear there's
one
there's, there's YAML linters.
Okay. The next thing we're going to do is I'm going to become a regular user. You can build packages as root, but you can also do it as a regular person. So I have this user named RHEL, who is like a regular person on the machine. And what we'll do is we'll make packages as this person instead of root, so that we can not have to be root on boxes when we don't have to be root on boxes. All right, next, we're going to set our packager string. So when we make packages, this is the attribution to whom the package will be assigned. All right, so I'm creating a packager macro, %packager, with me and my email. I'm going to put it in my home directory .rpm macros file. So there are system RPM macros elsewhere on the machine, but individual packagers can have their own RPM macros. An RPM macro is a token that starts with a percentage and then some stuff after it to tell what should be done or how it should be expanded when someone uses that percent tokenized value. All right. So now that I've identified myself, when I do things like create changelog entries and other stuff, this is the person that's going to go into those that metadata that goes with our package. All right, next we're going to set up the build environment for this person. And we're going to use one of those rpmdev tools that we installed earlier. It's called rpmdev setup tree. Whoop, that's not it. Maybe with more effective copy pasting, I can do the right thing.
Copy and paste the right piece of the output.
That's right. All right. So running a rpmdev setup tree. And what that does is it creates this rpm build directory and some directories underneath of it. And once we transition to the deeper dive, we can go into a little bit more detail on what these are for and how they're used. All right, then I'm going to go into the rpm build directory that we just made. And I'm going to move my source code from my application into the sources directory here underneath rpm build. So I've already downloaded a software package called Bellow. There's the source code for it. And I'm going to put it in sources. All right, then what we need to do is define a specification for how we want the RPM package built from this source code. And so, Nate, what do you think I need if I'm writing a specification?
What do you need if you're writing a specification? Perhaps a command line editor or a file that is the spec?
Yeah, you need a spec, a
Yeah.
specification. And again, we'll transition into the deeper dive. We'll talk more about what's contained in here, but I've already made one for us. I'm going to move it yellow spec. I'm going to put it in the specs directory. And so essentially it looks like this. We get the name of the package we're building, the version, release, a brief summary of it, what license covers it, where we can go to download the software if somebody wanted the source code, what source is out there on that URL, what architecture, what CPU architecture we are building the software for, a longer description about what this software is, and then we have the instructions for how we're compiling the package. And at the very
People
bottom,
might You might recognize that this is the information you'll get if you ask for information about the RPM from the RPM or DNF tools. So this
yeah,
is
so
important.
when you look at an rpm-qi to query a package for information, you'll get this section at the top, the name, version, release, summary, license, URL, description, all that stuff. All right. So I've got my initial specification defined. And now we're going to lint it. And that was one of the other tools that we installed to get going. So Nate, why do we want to lint our RPM content?
So the linter should tell you if you've got any syntax errors, right, within your spec file. And if you have errors when you try to build it, it could give you undesired results.
Right. The linter will also give you, notice there's a section for warnings too, right? So errors are like, if you build this thing, it's going to bomb out. A warning is like,
Right.
hey, your thing doesn't comply with recommended practices for building RPMs. You may need to add this thing, or you're missing this parameter that is usually found in spec files. So the linting helps you not only have successful builds, but it also helps you create a spec file that complies with recommended practices for making builds. All right, so since we've gotten a successful lint, now it's time to do the building. Let's try that again.
Zero. You have bellows 0. It should be 0.1.
There you go.
The linter didn't catch that.
Did not.
I assume that's because it's
Because
just checking for syntax.
hold on, I miss a step. I miss a step.
Uh-oh.
That's what happens when you miss a step. All right. We need to do one other thing. When we look at the spec, notice down under the change log that there is no change log. And you should have a change log entry, at least one, for your initial build of a package. And so there's another rpmdev tool called rpmdev bump spec. And this is why we're getting the error message, because notice that it does two things. One is it defines a new version number. The other is that it adds a changelog entry. So now when we look at the spec file, right, we have this changelog entry that got added in. And
Now,
up under version
specify
from
what
0.1.
can you specify what the changelog text says? I didn't see that in your command line. It might have been.
Yes. So if you look at the very
Oh,
top,
I see.
there's
New.
that
Okay.
comment in quotes. That's actually what goes underneath the changelog. But the reason we
Oh,
like
right there.
using the
Okay.
bump, yeah, the reason we like using bump spec is because notice that the date that's included in there,
Yep.
and it uses my packager macro that I defined earlier. And then
Yep.
it automatically adds the version information that we put into the thing. So bump spec is a really handy shortcut tool for putting these things in and knowing that they came in the right order,
Right.
the right format and content.
Right. So you could do that manually in the spec file, but bump spec just makes it easier and makes sure you're following the syntax and puts in the valuable information.
Yes. All right.
You
So
could have just made a change log that said did a thing.
yes. All right. So let me try it one more time. So we're going to RPM build BA on our spec. Oh, that's a link. Hold on. There we go. Okay, so this looks a little bit better. And what you will notice from that output is these two lines that it wrote some files out after it did its compilation of the RPM. When I called the RPM build command, I used two options. -B, because I wanted to build stuff, not some of the other things that the RPM build command can do. And -A, which says build all the stuff. All the stuff is both the binary packages that the spec defines, but also a source code package or an SRPM that the spec would generate. So that's what we see here in the rote. We see our source code RPM, that's the first line in the rote, and then we see our binary RPM in the second line of the rote. All right, so now if we look at RPMs, there's a new subdirectory for our architecture that we built for, and there is our compiled RPM, and we can install it.
Yay.
Maybe. We copy paste so I don't typo this one. Oh, helps if we also tell it to install the thing.
Yeah, just DNF-Y doesn't really tell it what you're trying to do. There we go.
Answer yes to all the things. All right, and so now that it's installed, I can run the bellow command that it provided, and there we go.
Awesome. We're now software packagers, Scott. Yay!
That's right, we built the first one. So that's the kind of steps that you go through when building your own software. You get the source code for your software, you put it in the sources directory. You write your specification, your spec file, and there's a standard that we use, and I happen to have one handy. You put that in the specs directory. You may need to do some things like add a changelog. That's why we use the bump spec command. And then we use rpm build to make the resulting RPMs. So join us after the transition where we talk a little bit more about these individual steps, and we can answer questions from the audience, and we'll go into a little bit more detail. All right. Well, thanks for joining us after the transition. I see in the chat that Carl George is here, and I do feel compelled to give Carl a tip of the hat. The lab that we're doing and the application that we just built, Bellow, and the instructions for doing it were actually created by Carl for a summit session that both he and I conducted at Red Hat Summit this year.
Which went splendidly, I'm sure, right?
Yeah, I mean, more or less, it worked as written.
Worked as written.
That's right.
That's a good dodge.
So, a lab URL in here too.
Right. So
Oh,
it's good to mention this is based on I guess the lab you're running here, right, is a live lab that folks can go and try out if you want to build your own RPMs, see how this works out. So if you need resources on how to build RPMs, not only I believe it's in the RHEL docs perhaps, but the lab is probably a lot easier and more intuitive perhaps, right? Because you get to interact with the
it's
command line a
definitely
bit
more
more.
exact. Like we give you the examples, we give you the like steps to build your spec file. In
Right.
fact, we can do another one if we're interested and have time. Because there are some things that we didn't touch on, right? So like we built a very basic spec file because we had a very basic application of a bash shell script. But
Right.
what happens when your thing you're packaging is a little more complex? And so the lab that I just threw into chat is actually packaging three different um, applications. One is the bash script that we just did together. Another one is a C program. And the third one, which I've got queued up if we want to go through it, is packaging a Python application. And then Carl also put into the lab a section on mock and using mock to build RPMs because you can do things like multiple architecture
Ah,
using mock.
there you go.
Or actually, we don't do multiple architecture. We use it for multiple versions. So you could build for like RHEL 9 and RHEL 8 using mock.
Which is handy because there was a time that building an RPM, you had to have different build infrastructure for different releases and different architectures and whatnot. So that's nice to know that it exists.
And Carl just gave a shout out to Adam Miller, who is a distinguished engineer at Red Hat and was the original author of this lab that we cut down to, I don't know, an hour or something ridiculous for Summit. All right. So, Nate, we wanted to, after the transition, talk a little bit more deeper about RPM.
Sure.
And so before we start into the actual what's there, and maybe we'll do some queries, but what is an RPM?
So I guess anyone who's familiar with pretty much any RPM based distribution, which Red Hat Linux was and Red Hat Enterprise Linux continues to be, I think since the very beginning. I don't know. Go way back in the annals of RHEL or Red Hat history. Maybe you'll find one that wasn't RPM based. But as long as I've been using it, it's been RPM based. And an RPM is basically a package. It's a compressed archive of a binary in the case of a binary, which is where you get that architecture from, or a script or whatever, which is what Scott had packaged just now. Um, and the whole concept is that you can absolutely build packages from source and then place them on your RHEL or any other Linux system. But RPM is meant to make that a lot easier. It's more akin to like a Windows installer where you just run the thing, it puts everything where it's supposed to be, and it makes sure that the system is actually in many cases configured to do the thing that you just installed, right? Which I guess we can touch on more a little bit later with things like post install scripts and whatnot that actually put things in place so that you don't just have software that now you can't or don't know how to use, right?
Yeah, and you're talking about the annals of history. So RPM used to, like once upon a time, stand for Red Hat Package Manager.
Hmm.
But like many of the things that we do at Red Hat, we contributed it back to the community. And RPM now stands for RPM Package Manager.
A
So the
recursive
R in RPM stands for RPM. Yeah, yeah. So Shantanu said CPIO. That is the format of the files archived within the RPM. But there's other stuff in the RPM too. So an RPM is really an archive of files, which happen to be packaged as a CPIO, plus metadata. So things like the changelog entry that we put in there, that's put into the RPM content. The files that are in there, the manifest of stuff that's in that packaged CPIO, that's in there. We have scripting that's in there, right? Because you might need to do things before the package gets installed on the machine to prepare it, or you might have to do things after the files have been smeared around the directory structure to like fix stuff up. It has file metadata, like you might want to drop a file in a directory, but it has to have specific file permissions and ownerships, or SE Linux contexts. So that can be in there. And then we have things like GPG signatures. So you can verify the authenticity of this package, that you got it from someone that you know and trust and meant to get it from.
Right.
So Nate, you want to do some queries?
Sure. I mean, we put all that metadata in there for a reason, right?
One would think. All right, so before the transition, we talked about the QI. So this is the information, a lot of the information that we put in our spec file, right? Name, version, release, sometimes referred to as the NVR. The architecture is compiled by. Notice that we do get a little bit of extra stuff that wasn't in the package itself, like the install date. So it actually gets put into the RPM database once you install the software. And then it fills out some things that we didn't specify in the spec file, like group or size in bytes of the content of the package. So the RPM building process actually puts in stuff that we didn't have to specify in the spec.
Right, because some of this is data that there's no reason for a human to have to create and put into the spec file, because it can get it from the files, and in fact, it'll be more accurate. So,
right.
It even tells you what host it was built on. Look at that.
It does. What other interesting queries would you like to find out about this package, Nate?
I don't know, Scott. Surprise me. What sort of data can we get out of RPM?
So we could do something like
you can list files, right? Show us what files it put in. Okay, the scripts. There you go.
Okay. So QL will query for a list of files. So when we unpackaged the CPIO archive of stuff, this is what came out of it.
Right. And if you're curious, you can unpack an RPM into like a non-installed directory using CPIO, but we're not really going to touch on how to get that done. Just know that you can do it if you need to get a file out of an RPM, for example. Like, oh crap, I just cooked the config file. I just need that thing back, right?
Yeah, and you could do something like a RPM reinstall.
Yes.
That would maybe give it back to you, but it would overwrite all the files that came from that package. So that may not be the best, depending on your situation, that might not be the best course of action.
Right.
All right, so here I asked for a query for the scripts that were included in Bellow, and it came back with nothing because there were no shell scripts that were executed as part of the Bellow package or weren't there. But these are the commands that you want to do before the package is installed, after the installed, before the package is removed, or after the package is removed. And so another one that has some interesting ones. Let's see if I have it installed. I may not. Oh, we do. Cool.
There you go.
Right. So here's an example of one that has some scripts, the HTTPD RPM. And you can see that there are 3 scripts in here. The post install script. So after the files and everything were put into the directory, this is what we do. Pre and uninstall. So before we remove it, if you do a DNF remove, and then a post uninstall. So after it cleans up all the files and stuff from the directory tree and removes them from your system, we do these things. And then there's a post transcriptlet. So that's like after the entirety of the transaction. So pre and uninstall is before an uninstall transaction. A post uninstall is after the uninstall transaction. A post transcriptlet is after the transaction has been executed.
Right.
And this actually ties into one of the other things, which is I mentioned that we had GPG keys, right? So Hold on, let me give it the actual file name. So if you're allowing someone to install software on your machine, and you're doing that as root, guess who the scripts are running as on your machine?
As root.
So it's probably important that you trust the content in there when you're giving someone root access to your machine.
Yeah, I mean, not just the scripts, but the binaries themselves, right? With it, in this case, it's a script, right? It's not a compiled binary. You could see what's in it, but with a binary, that becomes a lot harder, right? So yes, in general, you want to trust your software sources.
Right. So when we created our package, you'll notice that it was not signed because I didn't create a
Right.
GPG signing key for it. But if we look at something like, well, I'd have to download it. But if we looked at like the HTTPD RPM that we looked at earlier, it would actually be signed with Red Hat's packaging key that we use for signing packages distributed in RHEL.
Right, right. And the signature is, obviously you can use GPG to encrypt data. This isn't encrypting it. It's just saying this was created by Red Hat. By our packagers, we've signed it so that you know that that's who packaged it and released it. So it's basically so you can identify that chain. Who made this, where did it come from, that sort of thing.
All right. So yeah, that's kind of the metadata that comes with a package.
hmm Now, we didn't really touch on things like dependencies and package managers, right? Things like DNF. So back in the early days, you'd get an RPM, you'd try to install it. And if there were dependencies for that RPM, then you'd have to go hunt down the dependent RPMs or the other RPMs, the other packages, right? That particular thing you're trying to install requires in order to run. So you'd run into what people lovingly call dependency hell, where you'd try to install one package, it would require two others, those two would require four others, those four would require eight others, and that's being generous, right? So RHEL and many other distributions that are based on RPM come with package managers, like it was Yum for a very long time on RHEL. Now it's DNF, and that tracks down that dependency tree for you. So when you go to install an RPM using DNF, and it says, "Here's all the dependencies I'm going to install," it did all of the dependency work for you and found them in your repositories and allows you to install them automatically. It's really handy.
So Nate, on that tack, the other example I have queued up actually has some dependencies built into it.
Perfect. Now those
All
all
right,
get defined in your spec, right? Or am I ruining your demo here? Go ahead. Do
that's
your thing.
correct. Do my thing. All right, so let me copy some sources for the new package. Whoops, let's try that one more time. So most of the time we don't show this like side frame, but
hmm
man, I am sucking at copy paste today. But for the labs that we maintain, um, this is like the instructions pane.
Right.
So you can go through the lab and have a little bit of guided experience, whereas we tend to just like narrate it for you as we go through on ourselves. All right. So when we were doing this lab at Summit, Carl presented the sections of the spec together. And so there's like these little snippets that you use for making your spec. And so, for example, this first one starts creating the spec for this new software, Pello, which is a Python Hello World app. And it starts
Mm.
off with the name, version, release. Every spec file will have the name, version, and release in it. All right, the next thing is we'll add in the summary, which is a brief description of this thing, license, URL, where I can get it from, build arch. So this is a Python app. It's not being compiled as a binary, so no arc. And then notice that this one also has build requires. So build requires means when I do the RPM build command to make this this RPM, these packages are required to be installed on the build host. So that's what the build requires means.
Okay.
Okay, so we'll put in the description. And actually, I misspoke. I said it has requirements, but it doesn't. It has build requires. Shame on me.
Well, I mean, that's still a valid thing to call out, right? The machine that it's building on needs tools to build it from. This way, you're not left trying to guess what those are. The build process will tell you what they are. I assume that's what that will do when you try to build it, right?
I'm going to go off script and completely and utterly fail later when I put
I'm
in
sure
this.
this will be fine.
Yeah, who needs to check things? It'll be fine. All right. Um, so that's the preamble, right? The starting of our spec file.
Right.
And then we're going to add in the building instructions. So I'll put these all in here and then I'll open it up and we can take a look at what's happening in there. Okay. All right. So this section down here is what I just copied and pasted. And so after the preamble, which is kind of the header information that goes in my package, we then have the build instructions. And so there's two things that go into building. Actually, three things that go into building. Prep, which is I'm going to prepare the environment. And so what we're doing to prepare the environment for building is running this auto setup macro, which is going to use the Pello um, source content. So it might do something like unzip the content, move it under the sources subdirectory, and then uncompress it and untar it.
Right.
Right then under build, this is what we're doing to actually make the software. So if we were building a binary like a C program, we might see commands here like make, because we're compiling the binary. But here
Right.
for our Python 3, we're using a macro called py3 build, which is actually why we needed the Python 3 devel and Python 3 setup tools build requires, because the tools that are going to be called by that macro were given by those build requires parameters.
Now, RPM build will assume that the working directory is where it decompressed the source to, correct? So you don't need to specify all that. It does that for you.
Well, so remember in the very, very beginning of the critical path, we did the rpmdev setup tree,
Right.
and it created the directory structure. Here, let me get out of here to show you. It created this directory structure. And
Right.
these directories are very specifically named.
Right.
So when we say uncompressed source code, and we use a macro for uncompressing source code, it's going to default to look in the sources directory.
Right. Right.
And
So
when
when it runs the build, right, it'll know this is where I decompress the source to. It's in sources, in the name of the package. Boom. That's where it does the build.
so sources is where the source code lives. Build is where that source code gets copied and uncompressed and expanded,
Right.
because that's where we're going to do our building steps. Um, build root is actually for the next thing, which is the install section. And then once we've compiled and packaged and whatnot the software, source code RPMs are going to be dropped into sources. No, I'm sorry. They're going to be dropped into SRPMs, and binary or installable RPMs with actual software, they're going to be dropped into the RPMs directory and maybe into an architecture specific directory underneath that.
Right. Sorry, I'm busy heckling Eric in the chat. Important.
Oh,
Important work.
producer Eric. All right. So prep, we're going to take things from sources and put them under build and expand them and other stuff. Prep is also where we do things like if we have patch files, they would be applied to the source code. That would also be reflected, like what are those patch files to be reflected in the preamble.
Right.
All right, build, we're going to actually make the software, right? So if it's compiled software, we're going to do the compilations. If it is non-compiled software, we'll do whatever the py3 build thing says to do. All right, and then the third thing is install. So when we have an RPM and we install it on a system, it takes files out of that CPIO archive and puts them in places like bin and sbin and etc and all around the directory tree. So when we build that archive, we need to do it in such a way that when we pull files out, they go to the right locations on our target machine. And that's what the install section is doing. So it's going to install the files that we built in the build or that we have that we need to include in our application. It's going to take those and it's going to put them under the build root directory in our RPM building environment. So that py3 install, it's going to take the Python 3 stuff that we have under our build directory, and it's going to copy them into a directory structure inside of the build root directory. All right, and then we have a couple more small things to do. Well, maybe not so small, but. Okay, this section right here. And I'll go ahead and just finish it out with the changelog. Usually changelog happens at the bottom of your RPMs.
Mm-hmm.
All right. Okay, so the next section, after we have built it and we've installed the files into the build root, then we have this files section. The files section says, here's the manifest of content that my package is going to include. And so we can see that we've tagged one of the files as a license file. We've tagged one of the files as a documentation file. We've tagged or we're defining the Pello greeting, and we're going to put that in the binary directory on the target host. And then we're going to put two different files in the Python 3 site libraries on the target host. So that stuff that's before the actual file name, that's the directory structure where we're going to send this file when it gets unpackaged from our installed RPM. And we're using some RPM macros to be shortcuts to help us reference what those are. Like binder is probably user bin as an example.
Right.
Or maybe it's /bin. I can't remember which.
Now,
We could use a, yep.
Are these system-wide defined, or are these something you define somewhere else within your own environment?
So the answer is yes.
Both. Either.
Exactly. So because, and in fact, I only have one RPM macro now, right? In my home directory, RPM macros, right? This is what's in my RPM macros directory now.
Oh, right. You defined this at the beginning. Sorry, that was like 40 minutes ago. I've forgotten.
Right. So if it is these, then it's being pulled from my local RPM macro.
Right.
If it's the others like Binder or Python 3 sitelib, those aren't defined in my personal preferences. So it's using a system-wide defined macro. And so anything that you define personally will override a system-wide defined macro.
Right. Which is the usual flow for most things in Linux. If you've got a local definition, it overrides the system definition. And I see Carl George is very helpfully in chat showing us how to check on the environment using rpm-E and then the name of the macro.
Yes, to expand the macro. And you know what? I'm just going to do it because Carl George tells me to do things. I do them. All right. So
there you go.
when we say Binder, It's user bin, yeah. All right. So that's pretty much the end of the spec, right? We have the preamble that tells us a whole bunch of metadata about the thing. Prep build install is about unpackaging the source, building the whatever it is in the build directory, and installing it goes into the build root. And then files says, here's the files that are going to be included in the file manifest of my archive. Files is also where you could do things like specify ownerships or permissions or SE Linux contexts that should be assigned to those files when they're unpackaged or installed on the target host that your RPM is being installed on.
Does it otherwise respect whatever your SE Linux policy is defining? Right. So your policy says that user bin whatever has a certain context to it, it'll apply that, or do you have to then follow along and relabel?
It depends. So if you say this is the context that should be assigned to this file, that's what will be assigned to it when it gets unpackaged.
I meant if you don't define it, it'll just follow your policy.
Correct.
Okay.
So, or I shouldn't say your policy. I should say the policy that is currently in place on the machine that's having the RPM installed on it. And then there's some other things like what happens if you specify a policy that or a context that doesn't exist on the machine that you're installing it on. And so when that kind of stuff happens, it usually defaults to the system context for the place where we're putting that file.
Right.
All right. So let me do my bump spec. Down here at the bottom. And then we can build our package. All right, so when that's done, we'll lint it real quick. So it looks good. And then we'll RPM build. Actually, what's the BB this time?
So the build doesn't automatically install them. It tells you to go get them.
Oops, it helps if you spell the right thing. Python. Don't forget the Python.
The Pythons are important.
All right, let's try this one more time. Bam. So we're building a lot better this time now that I have all my build requires installed on the machine. And then where's my rotes? There it is. Rote. So we've written our RPM, and now we can do things like install it. And
Wait, did it
this is
install?
It did.
Install
This
your
is where
requirement.
JStar's comment about rpmql as the most used RPM command. Because like, wait, I installed it. Where did it go? Oh, it's called hello greeting.
Hello greeting. But no, you had put a requirement in there for HTTPD. Did it install that, or is that already there? Maybe.
It is already there. So, but yeah, we can remove it. How do we do that?
Now they should follow the dependency tree and say that. I was gonna say if you try to remove HTTPD, it should then have the dependency removal of Pello.
But yeah, we could do that. Too many dash Ys.
Too many Ys.
Oh God, no, it's too many. Man, what happens when we run off script, Nate? All right, so yeah, you can see that right here.
There it goes.
It removed HTTPD and it removed Pello as well. And if we put it back,
it should install HTTPD. Just up arrow, man. Hit the up arrow.
All right. Thankfully, we have just enough dash-wise. Pello is here. That's our target. And then because
Install
because we
Apache.
needed
Okay.
some dependencies of HTTPD, and then HTTPD installed these additional dependencies too.
Right.
So,
Right.
ooh, we're over time, Nate. It's a 45-minute into the
We
terminal
are.
today.
We are. The guy, the hair behind the glass has been letting us know that we're over.
Must obey the hair. All right. I just want to make sure real quick that we answered all the questions.
I think we did. There was some conversation about FPM, which, to be honest, I think it was answered in chat. So
It was.
okay, good.
All right. Great.
All right,
Well,
so this has been a fun ride down the RPM roller coaster. Call back to my
we,
initial comment that Scott didn't get.
we only had a few missteps. I even went off script and it worked, like with no problems.
Strange. I mean,
God.
you
Like
better not take any other chances the rest of the day. You've burned all of your luck.
look, it's not like I don't do this for a living, Nate.
Right, right.
Oh. So if
Ah,
you haven't already, the RPM lab that Carlos put together that I shared earlier in the episode is excellent. There is one more package that they have you build called Cello, which is CELLO. It's a C Hello World. So that one in the
ah.
build section actually does a make to compile the binary Hello World package. And then there's also a section on using mock, and you build your application for both RHEL 8 and RHEL 9, as opposed to just building for the operating system version of your build host. So it's good.
Sorry, I was just reading
All right.
Carl's comment in the chat about dependencies in DNF. Useful info.
So, Wolf, long ride.
Yeah,
Join us next time. Next
right.
time, now that we have our RPM built, what are we going to cover next time, Nate?
I think next time we're going to talk about how to build an RPM repository, right? And how you might manage a repository in a couple different ways that are supported on RHEL.
Yeah, so now that we have the RPMs, let's make a repository so that people can
Yeah,
find them and install them on their boxes.
yeah. Because
Uh,
fun fact, those package managers, DNF, Yum, whatever, they're not very helpful unless you have a repo to back them with.
Very true. And then also, RHEL Presents is coming up. And in RHEL Presents, Eric is going to be taking us through a practical guide to automating deployments in RHEL.
Yeah, I may be involved in that one too. So I'll see you guys next Wednesday.
I'm guessing it's Ansible stuff.
It was actually a talk that I was involved in at Summit that we're repurposing because it wasn't recorded at Summit because it's useful info about automating Image Builder basically with Ansible automation platform. So good stuff. Tune in. It's fun.
All right. So until next week, happy into the terminaling.
Yes. Happy and good. Have a good weekend, everybody. Have fun. Get out there. Do fun things.